Hi AB Calculus students. This is the 2019 test, question number 4. It's a separate and integrate question by the time you get to part C. Part A and B has more to do with related rates. Okay, listen, AP exams are hard. My students left the AP exam after taking the test this year and were like, oh my word, Mr. Bygate, sorry, I don't know how it went. It was my best year ever. The thing is, sometimes the harder the tests, the bigger the curve, and you get the points you can get. So go with what you know. Yes, it might seem difficult, but I believe in you, and you can do this. Now, a big word comes up that you will see in Part A and Part B. You see the word respect, with respect to time. If you see the word with respect to time, it 100% means it's going to be related rates. Now, here's what related rates means. Let's just take a quick, easy formula. If someone says, what's the derivative of a circle? When you take the derivative of a, instead of writing a prime, you get dA dt. Notice there's no time here. With respect to time means your hidden variable is time. It's basically like implicit differentiation, except everything gets a chain. So here the derivative of pi r squared, the 2 would go to the front, it'd be 2 pi r, and then you get dr dt. So the idea here is everything gets a chain with respect to time when you take the derivative throughout the whole problem if it says with respect to time. Okay? So part A says find the rate of change of the volume of the water in the barrel with respect to time when the height of the water is 4 feet. Now, a couple things. So we want to take the derivative of velocity. They give us velocity. Can I go home now? Okay. Of volume. They tell us the volume of a cylinder is pi r squared h. It's just a known formula, but in case people forgot it. And in this problem, there are not two variables. Variables are things that can change. The height of the water can change. The radius cannot. Now here they gave you the diameter is 2. That means the radius is 1 for the whole problem. So for the whole problem, that's not going to change. So if I make the radius a 1, I now have the volume is simply pi h. Okay. Now here they want us to find the rate that the volume changes with respect to time. So when I take the derivative of volume, I'm going to get not v prime, but dv dt, the rate that volume is changing with respect to time. And over here, what's the derivative of pi h? Well, if somebody said, hey, what's the derivative of like 3x, you would say 3. But if it was related rates, you'd put 3 dx dt. So it's the same sort of idea. The derivative of pi h is pi, but we get the chain dh dt. Now, how are we going to finish the problem? Well, we can finish the problem because we know what dh dt is. So dv dt is pi dh dt. And now we replace dh dt with what they told me dh dt is, which is negative 1/10 square root of h. And they want to know the rate that the volume is changing. Oh, this is all part A. Sorry. With respect to time at, is it time equals 4? No, when the height of the water, it can't be time equals 4. There's nowhere to put it in the 4 for t. It's when the height is 4. So the answer is pi, negative 1/10, and then you just put a 4 in here. And that's your answer. Did they ask for units? Yes. That means there's points here. Indicate units of measure. Well, if I want to know the units of measure for dv dt, it's the volume units over the time units. So here, volume, if it's in feet, volume is cubic units, so feet cubed, and then time. And in this problem, they say time is in, just looking for anything, seconds. Okay. Somewhere they said seconds, so it's seconds. And there you go. All right, that's part A. Alright, now let's go look at part B. So part B says when the height of the water is 3 feet, is the rate of change of height of the water. I'm just going to read it. It has a lot of ofs in there. Is the rate of change of the height of the water with respect to time increasing or decreasing? Now, your instincts might be wrong. You might think, oh, is the rate of change of height increasing or decreasing? Well, dh dt is the rate of change of height. I'll just put a 3 in there. I get negative 3/10. It's negative. It's decreasing. No. Nope. Okay. Let's just say if somebody gave you f of x and they said, is f of x increasing or decreasing? What would tell you if f of x is increasing or decreasing? It would be a sign chart of f prime x, right? When f prime x is positive, f of x is increasing. If f prime x is negative, f of x is decreasing. Well, what if somebody gave you f prime x and they said, when is f prime x increasing or decreasing? Well, to find out when f prime x is increasing or decreasing, you would look at its derivative, f double prime x. And the idea is that when something's derivative is positive, it's increasing, and when something's derivative is negative, it's decreasing. And it's basically, just look at the graph. Look at this graph here. Is the graph increasing or decreasing here? It's decreasing. And what do you notice when it's decreasing? Its slopes are negative, or its derivative is negative. And over here, when something is increasing, its slopes or its derivative is positive. So the idea is to find out if something is increasing or decreasing, you make a sign chart of its derivative. Or you now you don't have to even have a sign chart. You just need to find out, is its derivative positive or negative, where you're talking about. So the question is the rate of change of height, that's dh dt, is it increasing or decreasing? Meaning we need to look at its derivative. Now before I look at its derivative, I want to rewrite it as h to the 1/2 power. Okay. Oh, by the way, read the question. Do you see the words with respect to time? With respect to time, related rates. Part B is related rates as well. So we take the derivative, which is the second derivative. The 1/2 goes to the front, gives us negative 1 over 20. The exponent goes down by 1 times chain. And again, the chain, it's related rates. Everything gets a chain. So my chain is dh dt. And guess what? dh dt can be replaced with dh dt. I could move that to the bottom if I wanted to. If you move this to the bottom, you'll see that this and this will cancel out. Do we want to do that? Sure. You don't have to, but I'm just going to move that to the bottom just for the fun of it. And then dh dt is negative 1/10 height. And kind of the reason I wanted you to see this is, do you see how the heights cancel out? It doesn't matter that it says when the height of the water is 3 feet. It could say when the height of the water is anything. It actually doesn't even matter, because no matter what, those two are going to cancel. And when they cancel, you are simply left with, there's nowhere to even plug in the 3. You're left with a number 1 over 200. And 1 over 200 is positive. So remember, if someone's derivative is positive, that means it's increasing. So, because this guy is positive, the equation before it is increasing. So I would say this is this, which is positive. Therefore, I don't like writing out the word therefore. Those 3 dots means therefore. Therefore, dh dt is increasing at time equals, not time, at h equals 3. Alright, that's it for part B. And now we're going to go to part C, which is a separate and integrate question. Alright. So at time equals 0 seconds, the height of the water is 5 feet. Use separation of variables to find an expression for h in terms of t. So this is part C. And we're going to be using this. So if I start with dh, let me just go over here. The first thing I want to do is separate the variables. So I'm going to divide the square root of h over here, and I'm going to multiply the dt to the other side. Okay. Now, I'm ready to take the antiderivative. Before I take the antiderivative, I don't like this square root of h being down here. So I'm going to bring the square root of h to the top, call it h to the negative 1/2. And on the other side, we've got the negative 1/10 dt. So the antiderivative here, we add 1 to the exponent, multiply by the reciprocal. On the other side, just think if you had, hey, what's the antiderivative of 5 dx? Well, you get 5x plus c. So the antiderivative of a constant is the constant with the variable in front. So the antiderivative of negative 1/10 is negative 1/10 t plus c. Now, of course, at this point, we separate, we integrate, we have to plug in and solve for c, and they gave us some important information. At time equals 0, so at time equals 0, the height of the water is 5. Now, I'm going to change that h to the 1/2 power to the square root of h, and I'm going to plug a 5 in there. And you'll notice those cancel out, and you're left with c equals 2 square roots of 5. And we're going to plug it back in, and we're almost done. If we get h by itself, we win. All right. So I have 2h to the 1/2, or I like thinking of it as the square root of h, equals negative 1/10 t plus 2 square roots of 5. All right. So I need to divide by 2, and then I need to get rid of the square root by squaring. So I'll divide everything by 2. There's a lot cleaner way of doing this. I'm just trying to get points. I'm just going to divide it all by 2. A prettier way would be to multiply by 1/2. If you multiply by 1/2, that would make this negative 1 over 20, and then those 2's would cancel out. But I don't care about it being pretty. I'm just trying to solve h and get my points. Final step, destroy the square root by squaring. So if I square both sides, all this gets squared. And A, B, and C weren't insanely... The work wasn't hard. Now, knowing how to do it may be something different. But the key here, with respect to time, related rates, meaning everything gets a chain. Derivative of x has a dx dt as a chain. The derivative of y has a dy dt. R has dr dt. H has dh dt, and so forth. Anyways, thank you for watching. Bye.